Hi friends, good afternoon one and all. First of all, I would like to introduce myself. So before going, I am from TTWREIS, Narsapur, Medak. My name is J.Srikanth. So I am pursuing first year MPC. So before entering to our topic, let us start our topic with the questions. Okay. So yes. So first of all, what is atom? What is inside the atom? What are the subatomic particles? Then they are present inside the atom. And what is meant by Thomson model, and what is meant by Rutherford model, and what is meant by Bohr's model. And by learning this model, what is useful for us to understand this various question, let us start our topic that is named as atomic structure. So friends, atomic structure is nothing but, for example, this is an atom. You consider this is an atom. To learn about the internal structure of an atom is called atomic structure. Okay, learning about internal structure of atom is called atomic structure. So friends, if you want to construct a building or if you want to build a building, we need some planning and materials required. In the same way, if you want to construct our topic, if you want to build our topic in a high range, we need some fundamental principles, that is nothing but definition about what is atom, what are the fundamental subatomic particles, and let us learn. So friends, let us see a video. Atoms and molecules. This is an ant hill. The ants are busy building it. It takes many small grains of sand to make an ant hill. And if you take a close look under a tunneling microscope, these small particles consist of millions of tiny particles. These particles in a miscellaneous nature, these particles are called atoms. So atoms are fundamental principle of all matters. So here there are three subatomic particles inside the atom: electron and proton and neutron. Atom has central nucleus with protons and neutrons, where proton is positive charge and neutrons are negative charge, no charge, and finally nucleus is positive charge. And collectively protons and neutrons are called nucleons, and electrons are negatively charged. They are located around the nucleus, and in an atom the number of electrons as much as equal to number of protons. Hence atom is electrically neutral, and electrons are revolving around the nucleus in a particular path. This path is called shells or orbits. This concept was introduced by Niels Bohr. According to Bohr, the atoms are revolving around the nucleus in a closed circular path. This path is considered with solar system, where the sun acts like a nucleus and the planets act like electrons. In this manner, where they are equal to electrons revolving around the nucleus. So these in its own orbit, these orbits are represented by KLM shells. KLMS shells. So friends, I hope you understand what is meant by atom. Yes. So atom is nothing but a small unit of matter that can be retraced back in opposite direction. Okay. Atom is nothing but the smallest unit of matter that retains the identity of substance is called atom. Or simply, friends, let us take a chalk piece and break down into small pieces until we get powder. So after that we can get powder. We cannot break the chalk piece further. Yes. So we cannot further divisible. Yes. So atom in video we saw atoms are we can see only under tunneling microscope. Yes. So that is simply atom, or atom simply as invisible or undestructible or undivisible particles are stated as atom. Okay. So friends, atoms are first proposed by Democritus. So friends, the scientists did various development to learn about the internal structure of an atom. So one of them is Thomson atomic model. Okay. So let us take a look onto the slide, friends. So this model is commonly called as plum-pudding model. This model was introduced by J.J. Thomson in the year of 1904. Yes. So in this model, Thomson compared with watermelon, where in watermelon the whole positive charge is called nucleus, and where the electrons are negatively charged, that is nothing but we have black colors in watermelon. Okay. So he concluded as totally the negatively charged embedded in positively charged, and the atom spread throughout the nucleus. Okay, so in this way we can learn Thomson atomic model. And let us take another model, that is Rutherford model. In Rutherford model we can observe here source of alpha particle and lead plate and alpha particle rays and thin gold foil and fluorescent screen. So these are arranged in a sequence manner. So inside around the fluorescent screen we are insert a thin gold foil. So if you look at thin gold foil as systematic array, when we see the systematic array, most of the alpha particles are passing through thin gold foil. As he concluded, most of the space inside the atom is empty. Okay, most of the space inside the atom is empty, because if there is no space inside the atom, how they are passing? Yes, how they are passing? So here is there space inside the atom, that's why they are passing through this thin gold foil. And second one, if you are bouncing back with 180 degrees, okay, if you are bouncing back with 180 degrees, because here concentrated mass at the center is present. Okay, so because when the concentrated mass is present, this is nothing but nucleus. In nucleus the protons and neutrons are present, so there is no space inside the nucleus. Then how they pass the alpha particle? So that's why they are bouncing back with 180 degrees. And that third one, some are other are deflecting at various angles. They are that means, as he concluded Rutherford, repulsion between positive and positive charge. Okay, here nothing but the repulsion between positive and positively charged. So here alpha particle nucleus is, in video we saw the nucleus is positive charge, and in the same way alpha particles are positive charge. So positive repulse each other, we know. So as the result, positive repulse each other, they are deflecting with some angles. Okay, so to understand in a better manner Rutherford, let us come do one activity. Okay, so friends, take one apple. We know this is an apple, yes, and these are the broomsticks, yes. So these are the broomsticks. Okay, so when we are inserting this broomstick through apple, okay friends, let us remember carefully and observe carefully. Okay, so now I am inserting this broomstick along apple, through apple. Okay, so in the way, observe. Okay, friends, are you seeing? Observe carefully. So let us see friends how this is looking. So we know this is an apple, but a few seconds you think in your mind this is an thin gold foil array. Okay, systematic array, and these broomsticks you think like as alpha particles. Okay, so when in first concept the Rutherford concluded most of the alpha particles are passing through thin gold foil. As he concluded, most of the space inside the atom is empty. Okay, if there is no space, how these sticks are passing through this apple? Yes, isn't it? So most of the space inside the atom is empty, as that they are passing through this apple. Yes. Okay, next, second is some are other deflecting at various angles. Yes, are you seeing? Some are other deflecting by some angles, because the repulsion between positive and positive. Okay, because here the positive repulse each other and they are making an angle. Okay, so that is. And third one, if you are bouncing back with 180 degrees, are you seeing here? Only one stick is bouncing back, because if you are bouncing back in Rutherford atomic model, as he concluded, the presence of concentrated mass at the center is present. That is nothing but nucleus. So is there nucleus? Then how it is not passing through this stick, through apple? Why it is disturbing to this alpha particle, not passing through this apple? So let us see, is there nucleus or not? So take knife. Okay, so cut the apple gently, friends. Okay, cut it gently. Friends, are you hearing? Are you seeing? Remember? Yes, friends. We know this is an apple seed. Yes, this is an apple seed place. But you think this is according to according to Rutherford atomic model, this seed is called nucleus because it is present at the center of the apple. So this is considered as nucleus, and where here this broomstick has alpha particle. So friends, I am trying to push this stick forward, but it is not moving easily. Yes, it is not moving easily. So because here the neutrons and protons at the center of the nucleus are present, there is no space inside this. So that's why they are bouncing back with 180 degrees. Okay. So this is about the Rutherford model. So let us see in our day-to-day life we do various mistakes. Yes, in our day-to-day life we do various lot of mistakes. So in the same way, in those days also Rutherford did some defects in his atomic model. So let us learn a few defects in Rutherford atomic model. Okay. So the accelerating electron should emit radiation. Okay. Then by losing energy, the electron should spiral into the nucleus. Yes. Hence, ultimately, the atom should collapse. In fact, this doesn't happen, you know. Yes. In fact, it doesn't happen. That means, this is one of the main defect of Rutherford atomic model. And second one, in the Rutherford model, could not explain the stability of an atom. Here, Rutherford model could not explain the stability of an atom. Okay. Are you remembering, friends? Next, third one, the Rutherford model could not explain the electronic structure of an atom. This is the main drawbacks of Rutherford, nothing but limitations or defects in Rutherford atomic model. So, friends, let us see, this is the present and running the atomic model, that is nothing but Niels Bohr atomic model. Niels Bohr atomic model is very interesting. Niels Bohr atomic model is not an boring topic, it is an interesting topic. Let us see. Before going to Bohr's atomic model, learn about a few interesting facts about Bohr. Yes, let us see. Take a look on the slide. His father was nominated for Nobel Prize 3 times in 2 years, and he disagreed with his professor plum flooding model. Means here plum flooding model was done by Thomson. So Bohr's professor is Thomson. So he nailed the true structure of an atom in 1913, and he won the Nobel Prize at the same time and in the same field as Albert Einstein in nothing but physics. They got Nobel Prize, and his son again also won a Nobel Prize. Oh, what is such a glorious family! Then they're all we can say what a noblest family. They all got Nobel Prizes. Yes, it is very interesting topic, So let us see Bohr's atomic model. So friends, the accelerating electrons move around the nucleus. Yes. The accelerating electrons move in a fixed amount of energy in an orbit of an atom. These orbitals known as energy levels or quantum levels. Energy levels or quantum levels. The energy of an electron is quantized. And take another slide. In this slide, there is excited station and there is atomic de-excited station. Then let's learn about what is excited state, what is de-excited state. So, okay, when an atom absorbs energy, it will move from ground state to higher energy level. That is called excited state. If you take a daily life example, when we are standing under a mango tree, okay, the mango tree has full of mangoes. So I am very hungry now. Okay, I am very hungry. I have no enough energy. I want to gain energy. If I want to gain energy, I want to absorb energy. What can I do? Nothing. I immediately want to climb the tree and eat the mangoes. Yes. So I eat the mangoes. After that, we get down immediately, yes, because if we sit there after eating, we are unstable, yes, we are unstable, so we are immediately get down from tree. So in the same way, when an electron absorb energy, it will move ground state to higher energy level, that is called excited state, and the excited state is unstable. Excited state is unstable, as that the electron will be lost energy and fall back to the lower energy levels. This energy will be rated as light. The light emitted with a discrete amount of energy is called photon. The energy of an photon is equal to difference between two energy levels. Friends, remember, the energy of the photon is equal to difference between the two energy levels. This equation given by delta E is equals to EF minus EI. Delta E is equals to EF minus EI. Okay, friends, where the energy of a photon is equal to the difference between two energy levels. That is equation given by delta E is equals to EF minus EI, where here EF represent outermost energy level and EI represent innermost energy level. Okay, so the frequency of the emitted or absorbed, the frequency of emitted or absorbed light is related to the equation given by E is equals to h nu, where here h represent Planck's constant and V represent visible light. And take another slide. We are seeing something in slide, that is emission spectrum, absorption spectrum, yes, yes. Then how they are formed, how we are seeing, yes. So let us see. Elements can have be identified by the light emissions. Okay, elements can have be identified by their light emissions. So for example, sodium is yellow in color. How sodium is in yellow in color means, so when the sodium is emits its energy, we can see in spectrum, so then only we can identify it is as sodium, and the sodium color is yellow in color. And the same way potassium also blue color, it emits blue light, so that's why it is a blue in nature. So elements can have be identified by their light emissions. Okay, and absorption spectrum is when the light is absorbed is analyzed, and an emission spectrum is when the light produced is analyzed. Here nothing but absorption spectrum is when the light is observed, emission spectrum is formed, and when the light is emits means nothing but when light is produced energy, we can see emission spectrum. And if you take another slide, we know, friends, in our class we learn about prism. Yes, we learn about prism, where a light is passing through a prism, it deviated as Vibgyor colors. Yes, yes, deviated as Vibgyor colors. So here in our topic, when the white light ray is passing through any medium, it can be shown in continuous spectrum. In continuous spectrum only we can see all Vibgyor colors. In no other spectrum we cannot see. So hot gas. Second one is hot gas. Hot means hot is always emits energy. Energy means heat. Hot means hot always emits energy. So hot when emits energy, it will be seen in emission spectrum, and when cold gas absorb energy, it can be seen in absorption spectrum. So friends, before we have learned this what is excitation, this all things. So let us learn about a Niels Bohr atomic spectrum of hydrogen line spectrum. Okay, so hydrogen line spectrum is formed, when it is formed, how it is formed, what are the colors. Okay, so let us see the Bohr's model. The electrons revolve around the nucleus. Yes, the electron revolve around the nucleus in a closed circular path. This path is called shells or energy levels or quantum levels. So when an electron revolving around the nucleus, it neither loss, it neither gain, energy. It like either loss, it neither gain energy. Okay, so these orbits are called stationary orbits. So when the electron should lose energy or gain energy, yes, it is fact, but when the electron tries to move from one energy level to another energy level, then the light is formed. This light is seen in hydrogen line spectrum. So let us see hydrogen line spectrum. So when the electron of hydrogen line spectrum goes into excited state, after that few seconds it come back and fall back to the lower energy levels. So when electron goes into higher energy level, and from higher energy level, when electron falls from higher energy level to low energy level, this region is called ultraviolet region, or this series is named as Lyman series. And in the same way, when an electron falls from a higher energy level to lower energy level, this series is called Balmer series, and this series we can see the region, it is nothing but visible light. In this region only we can see with our naked eyes. In this region only we can observe Vibgyor colors. Okay, and when electron falls from a higher energy level to third energy level, we can see this series as Paschen series. So in this series we can observe the region infrared region, means infrared rays, and when the electron falls from a higher energy level to fourth energy level, this series is named as bracket series. So when this series is called bracket series, and this region is named as near infrared rays, and when electron falls from a higher energy level to fifth energy level, this series is called Pfund series, and this region is far infrared rays. Okay, so friends, a decision reached by my reasoning, in the human atoms and molecules, the chemical basis of life. In the human's body also an atom plays a vital role. For example, we are breathing, it is oxygen for living, yes. However, oxygen is a diatomic molecule. Molecule is nothing but combination of two atoms. For example, this is one atom and this another atom. The combination of two atoms is called molecule. So in the world, all the things are made up of matter, and everything is made up of matter. In this matter, atoms acts like a pillar to construct the matter. So finally we can conclude that atoms play a vital role in humans' need as well as in the world. So I hope you understand what is atom, and what is meant by Rutherford model, and what is meant by Thomson model, and what is meant by Bohr's model. By learning this model, what is essential for is, so finally I think that you understand what is atomic structure. So these are the atomic structures of an atom. That is nothing but, this is the structures of nucleus and subatomic particles. So finally I am thankful for our beloved secretary, who is trying to bring out the marginalized children from garage to galaxy. And today I am here because I shall never fear the unknown. This commandment taught me a lot. So the secretary Dr. R.S. Praveen Kumar sir. So I am also thankful for our principal Vairagapati sir and subject guidance Parike Ramu sir and P. Srikanth sir. And I am also thankful for viewers and the media. And these Gurukulam institutions are turning me as a melting of candle to give the light for the society and pay back for the society. Jai Bhim, Jai Swero. Thank you one and all once again.